All right, so today we're going to start looking at how we can determine differences in atoms and how we can start determining the numbers of protons, neutrons, and electrons within an atom. So, what is it that we know makes an atom different from another atom? We talked about this a little bit in the last video, but what makes atoms different from one another? Is it their numbers of electrons, their numbers of protons, or their numbers of neutrons? Okay, the thing that makes atoms distinctly different from one another is their number of protons. I could have two atoms that both happen to have 20 neutrons. But if they have different numbers of protons, that is what distinctly makes them different. Okay, so I could have an atom with 20 protons and 20 neutrons. That would be calcium. But if I had 19 protons and 20 neutrons, these are not the same atom just because they have the same number of neutrons. In fact, they are different atoms because they have different numbers of protons. So this would be potassium. Okay, so we need to understand that protons are what makes elements different from one another and makes atoms different from one another. The number of protons that an atom contains is called the atomic number. This is extremely important that we know that that's called that. The atomic number is the number of protons in an atom. That's super, super, super important. So the atomic number on the periodic table, right? You should have a periodic table in front of you now. If you don't have one, please make sure that that gets passed out. But we're using the periodic table side, not the periodic table of ions side. So check to make sure that you're looking at it correctly. This is not the side of the periodic table with charges. This is the side that has atomic mass and atomic number on it. So the atomic number is usually listed in the top of each box. I'm actually not sure on your periodic table where it's listed, but the atomic number has to always be the whole number. Okay, because it's a set number of protons. So the atomic number is the whole number that's given to you. Usually it's listed in the top. It might in this case be listed in the bottom, but I do think it's listed on the top of the box somewhere, maybe in the middle, but it's a whole number because it's this just a straight number of protons that each atom contains. So if we're looking at Ag or silver, you'll see number 47. I also want you to notice that on your periodic table, your atoms go in the order of atomic number. So starting in the top left with hydrogen, it has an atomic number of 1. Then over to helium has an atomic number of 2. Lithium is 3. Beryllium's 4. Right? We go all the way over here. 5, 6, 7, 8, 9, 10, right? Our periodic table is listed left to right and then down in order of atomic number. Okay, so it goes by the number of protons. So when I'm looking for atomic number 47, it should be really easy for me to locate on the periodic table. Okay, the number of protons in a particular atom or a particular element never changes. So silver, for example, Ag here, will always have 47 protons. We said the number of neutrons can change. We even know the number of electrons can change, but the number of protons never changes because if it does, it's no longer that element. If this goes from 47 to 48, now it's not silver anymore, it's the next element. Okay, or if it would go from 47 to 46, it's not silver anymore, it would be the previous element. So the atomic number of the particular element will never change. So if I'm looking at oxygen, if you locate oxygen on your periodic table, oxygen is an O. It has an atomic number of 8. It will always, always, always have 8 protons. Okay, the number of protons also tells us, or the atomic number, it also tells us the number of electrons in an atom as long as that atom is considered neutral. Right? We said an atom is considered neutral if the number of protons equals the number of electrons, right? Neutral means my overall charge is 0, right? A neutral atom has no overall charge. So if I have an atom that has 8 protons, that would be oxygen, and my number of electrons in that atom is 8, that would mean my oxygen atom has no overall charge. If I had 8 protons and 9 electrons, my atom is no longer neutral. That would mean my oxygen atom has a -1 charge because I have one more electron than protons, or one more negative charge than a positive charge. And we're not quite there yet, but I want you to see that if I've got a neutral atom, which is what we're going to start with, my number of electrons is equal to my number of protons. So let's look at this one. How many protons and electrons do each of the following neutral atoms have? So if I know my atom is neutral, that has to mean that my number of protons equals my number of electrons. All right, so I pulled up a periodic table here so I can see it on my screen as well as you can see it as well, but you should have your periodic table up while we're working through this. So how many protons and electrons do each of the following neutral atoms have? So calcium is Ca. On the periodic table, calcium is right there. Okay, so locate that on your periodic table as well. But if I'm looking for the number of protons and the number of electrons in a neutral calcium atom, the first thing I do is look at its atomic number, right? And the atomic number for calcium is 20, which means it has to have 20 protons. Now, if my atom is neutral, I know that my number of protons has to equal my number of electrons. And so that means my electrons must also be 20. So let's look at argon here. Ar is an element called argon. It's over all the way on the right-hand side of the periodic table right there. Okay, argon has an atomic number of 18, which means atomic number represents the number of protons to be 18. And if my atom is neutral, that means my electrons must also be 18. Okay, I want you to try the last two on your own here. So go ahead and pause the video. I'll kind of tell you platinum is right here, PT, and rubidium, or RB, is right here. Okay, so there's the two for you to be looking for on your periodic table. Go ahead and pause it and look for those yourselves, and then you can carry on with the video. So PT is called platinum. Its atomic number, or number of protons, is 78, which means my electrons must also be 78. And my last one, rubidium, has an atomic number of 37, which means my electron numbers must also be 37. Okay, so for all of these cases, them being neutral means that my protons and my electrons must be the same. I can always identify the number of protons based on the atomic number given to us on the periodic table, right? That whole number right there always is telling me the number of pure protons in an atom. So we've got the ability now to find the number of protons and electrons in neutral atoms. Now we're going to start looking at neutrons, okay? And to get to neutrons, we have to know something about what's called the atomic mass. Atomic mass. Sometimes the book or your CK12 might call it mass number, but you'll always hear me call it atomic mass. And the atomic mass is the total number of protons plus neutrons in the nucleus of an atom. Okay, so atomic mass is protons plus neutrons. That's what equals atomic mass. Protons plus neutrons. That's super, super important. Okay, atomic number is protons only. Atomic mass is protons plus neutrons. This number is usually listed at the bottom of the box on the periodic table, and the number that you see listed in your periodic table is an average of all the atomic masses of all the different versions of the element. So for this silver example we showed you earlier, the atomic mass is 107.8682. You'll notice that's not a whole number, right? It's not just protons plus neutrons. It's an average of all of the different masses that silver could have. Okay, it's an average of all of the different masses silver could have. Now we'll get into that part a little bit more as you get into chemistry, but I want you to understand that this mass right here that's given to us is an average of all of the masses that different silver particles could have. Okay, but let's say when we look at this, I might tell you to round this number up to the nearest whole number, which would mean you would call the mass 108. And that would be the total number of protons plus neutrons. Okay, so we'll be able to still do the math with it, but we might have to round it a little bit. Okay. So this number is atomic number, just protons. This is atomic mass, which is protons plus neutrons. So let's go ahead and look at finding out how many protons, neutrons, and electrons are in the following neutral atoms. And let's look at oxygen here. So I want you to locate oxygen on your periodic table. I'm going to pull my periodic table back up here. All right. If I want to find oxygen, it's way over here on the right. So if you look at your periodic table, you'll know that the number of protons has to be 8. The number of electrons, since it says it's neutral, also has to be 8. And then how can we determine the number of neutrons? Right? I'm going to look at the atomic mass for oxygen. It's actually not even listed on my periodic table here. But if you look on your periodic table, the atomic mass comes to 15.999, right? For our purposes, we're going to go ahead and round that up to 16. And we're going to say it has an atomic mass of 16. So if I know I'm looking for the number of neutrons in a neutral oxygen atom, and I know it has an atomic mass of 16, I know that that's equal to protons plus neutrons. 16 is equal to 8 protons plus how many neutrons? Right? All I need to do is subtract out the number of protons from my atomic mass, and that would give me my number of neutrons. right? So that means neutrons has to be 8 as well. I took my atomic mass, 16, and I subtracted out my number of protons, which was 8, leaving me with 8 neutrons. It does not always happen that they have the same exact number. It does not always happen. That's not always the case. It happens more often with these elements up top, but once you get down to the bottom, they typically have a lot more neutrons than they do protons. All right, so if I'm looking at these, we said protons, neutrons, and electrons were all 8. And let's recap here how we know that. Okay, how do we know the number of protons? Since the atomic number of oxygen is 8, it has to have 8 protons. My neutrons, if my atomic mass of oxygen is 16, and I take away my number of protons from that atomic mass, that leaves me with 8 neutrons. And my electrons, it says my atom is neutral, so protons and electrons must be equal, which is how we got 8 on that one as well. Let's try a couple more here. Find the number of protons, neutrons, and electrons in the following neutral atoms. All right, I grabbed a different periodic table here so we could see the atomic mass on all of these, since we will need that. But we know that it says our atoms are neutral. So let's go ahead and locate the elements we're looking for here. Sodium, right up here on the left-hand side, it has an atomic number of 11. That automatically tells me that my number of protons is 11. It also tells me, because my instructions said that we're looking for protons, neutrons, and electrons in a neutral atom, that my numbers of electrons must also be 11. So the last part I'm looking at here is I need to find out my number of neutrons. And so to do that, I need to take the atomic mass, which for sodium is 22.99. I'm going to round that up to 23, and that's going to be something we do most of the time. If 22.99 is an average of all of our masses, that means most of the time it's got a mass of 23. So I would take 23 minus my atomic number, which is my number of protons. So 23 minus 11, and that would tell me that I have 12 neutrons in this particular sodium atom. So my protons is 11, my neutrons is 12, my electrons are 11. Okay, to find neutrons, we take atomic mass minus atomic number to give us the number of neutrons. Okay, let's look now at silicon, or silicone, however you want to say it. Silicon is over here, kind of on the right-hand side, right there. Silicon has an atomic number of 14. So that has to be my number of protons. Since it says my atom is neutral, that also must mean it is my number of electrons. And so to find my number of neutrons, I take its atomic mass, 28.086. So I'm going to round that. And your numbers might be a teensy bit different on your periodic table, but they're going to be pretty darn close. So I'm going to just round that to 28. That would be the atomic mass. I'm going to subtract out my atomic number. And that gives me 14 neutrons. So again, it doesn't always happen that these three numbers are the same. That's coincidental. So don't Don't get into a pattern, right? Because it was not the case in our first example here. But it does happen fairly often, especially for these elements up kind of in the top section of the periodic table. It tends to happen a little bit more, but it's not always something you can count on. All right, I want you to try a couple more of these on your own. These aren't on the actual slide, so I want you to find the number of protons, neutrons, and electrons. Protons, neutrons, and electrons in the following neutral atoms. So exactly what we've been doing. I want you to do that for a few more here, and I want you to just pause it and do it, and then I'll have the answers for you when you unpause that video. So let's do fluorine. Fluorine is just an F. So you're going to have to locate that on the periodic table. I want you to do scandium, which is SC. So I want protons, neutrons, and electrons. These are all going to be neutral. And I want you to round their atomic masses to the whole number, right? To the nearest whole. And last one I want you to do is phosphorus. It's just a P. So you're going to have to find protons, neutrons, and electrons. Okay, so you've got 3 of them I want you to do on your own. Pause it, go ahead and do the work, and then once you're done, I'll have the answers up here for you. Fluorine would have 9 protons and 9 electrons. The atomic mass of fluorine rounds up to 19. So 19 minus 9 would mean I would have 10 neutrons. Scandium is here on the left side. Protons and electrons would both be 21. And to find my number of neutrons, I round its atomic mass up to 45. So 45 minus 21 leaves me with 24 neutrons. And then my last one was phosphorus. So there's phosphorus here, protons and electrons. Since I told you the atoms were neutral, are going to be equal to one another, I'm going to round 30.97 up to 31. I'm going to take away the number of protons, and that leaves me with 16 neutrons. All right, so now we've gotten really good at identifying the number of protons, neutrons, and electrons in neutral atoms. We're going to move into atoms now that don't have a neutral charge. We're going to move into atoms that do have a charge. They have different numbers of protons and electrons. So these are called ions. Okay, if an atom has a different number of electrons than protons, it is called an ion. They have different numbers of electrons than protons. And so an ion is really any atom that has a positive or a negative charge. Any atom that has a positive or a negative charge. You will know if an atom has a charge because the charge will be written up in the top right. So if oxygen has a -2 charge, it's written up here almost like an exponent. Okay, it's written up in the top right section or up and to the right of that atom. So that would be oxygen that has a -2 charge. This might be potassium with a +1 charge. Okay, this would be phosphorus with a -3 charge, right? The charges are written up and to the right. If an atom does not have a charge, it would just be written plain, just like that. Oxygen, no charge written up here, right? So if it has a number up here, that means my numbers of electrons and my protons are different. If it does not have a charge written up to the top right, that means it is neutral, and that means my electrons and protons would remain the same. Okay? So let's say that my atom has more electrons than protons. More electrons than protons. So let me look, for instance, at an atom that has 8 protons. You should first be able to tell me what atom is that, right? There's only one atom that could have 8 protons, and it has to be oxygen. Right? Look on your periodic table and see which element has an atomic number of 8. Right? If it has 8 protons, it has to be oxygen. But let's say I've got more electrons. So let's say I have 10 electrons. That would leave me with a charge of -2. Right? I have 2 extra electrons. I have 2 extra electrons, which means I've got 2 more negatives than positives, which leaves me with a charge of -2. And so the ion that would be like that would be listed O -2. Because I have 2 extra electrons. Sometimes it's easy to think that if I have extra, well, it's got to be a +2. Well, that's not the case because electrons have a negative charge. So if I have 2 more negatives, that means I've got to have a -2 charge. Sometimes you'll even see it written like this, O with a 2 minus. Both of these things are identical. I typically write them like this with the -2, but you'll see CK12 or some things list them 2 minus. That means the exact same thing. Okay? But if I have more electrons than protons, that's a certain type of ion called an anion. Anions always have a negative charge. Anions always have a negative charge. That means I've got extra electrons. Extra electrons is anions. Okay? So that might be O -2, F -1, Cl -1, right? All of these are examples of anions because all of their charges are negative. Okay, on the opposite side of that, if I have less electrons than protons, okay, so let's say I have 3 protons. You have to identify what element is that. What element has 3 protons, has an atomic number of 3? And you would tell me it's lithium. Right? Lithium has 3 protons. What if I only have 2 electrons? 3 positives and 2 negatives leaves me with a +1 charge, which means it would be written as lithium with a +1 charge. Right? I've got 3 positives and 2 negatives. That leaves me with a +1 charge. Okay? So anytime we have less electrons than protons, that leaves us with a positive charge, and these are called cations. Cations. Cation. Okay, I remember cation is the positively charged one because it has a plus sign right in the word. Okay, cations are positive. It has a plus sign right there in the word itself. So if you can remember that, you'll know that anion is the negative and cation is the positive charge. So examples of cations could be potassium +1, rubidium +2, right? Silver +1, because all of these charges are positive, right? That's what makes them a cation. All right, so we said if a neutral lithium atom loses an electron, what is it? So we actually already kind of looked at this example. Lithium neutral has 3 protons because it has an atomic number of 3. And if it was neutral, it would have 3 electrons. But it's asking us what happens if it loses an electron. And so now it's not 3, but it's only 2 electrons. That would leave me with a charge of +1, right? 3 protons and 2 electrons would leave me with a charge of +1. And so I would write it as lithium +1. Right? That would be my cation called lithium. If a neutral oxygen atom gains 2 electrons, what is it? We actually kind of looked at this one as well. So oxygen normally has 8 protons. And if it was neutral, it would have 8 electrons. But it says it gains 2 electrons. So it doesn't have 8 anymore. It has 10 electrons. 8 protons and 10 electrons leaves me with 2 extra electrons, which means I've got a -2 charge. And so if I was going to write that, I would write it as O -2. Okay, so tell me this. What ion would have 16 protons and 18 electrons? So I need you to look at your periodic table. And we've got to figure out, well, first of all, what element has 16 protons to begin with? I'm going to look up which one's atomic number 16. Right? Well, it's right here. It's sulfur. So sulfur has 16 protons, and it's telling us it has 18 electrons. And so what charge does that leave me with? Well, I've got more electrons, so it's going to be a negative charge. And I've got 2 more electrons than protons, which means it's going to be a -2 charge. So I would write it as S -2. And that would be my ion that has 16 protons and 18 electrons. I know it's sulfur because I found atomic number 16. Right? That's what I was looking for there, and I knew it was sulfur, which is an S. How many electrons would a chlorine -1 ion have? Okay, so I've got to, again, on my periodic table, I've got to locate, well, where's chlorine? Where's chlorine? Okay, chlorine is way over here. Okay, so let's see, chlorine -1. Let's look at how many protons does chlorine have, because that number never changes. Even based on its charge, the number of protons does not change. So chlorine always has 17 protons. Now I can find out, well, how many electrons would I have based on the fact that we're looking at a chlorine with a -1 charge. -1 does not mean we take an electron away. It means we have an extra negative charge, an extra electron. So that would mean I would have 18 electrons in a chloride anion. Right? Cl -1, this would be an anion because it has a -1 charge. All right, I want you to try these two on your own. How many protons, neutrons, and electrons are in each of the following ions? So you're going to have to locate the element, and then the charge is listed right there. So you'll have to find protons, neutrons, and electrons. So go ahead and pause the video, and then I'll have the answer up here in just a minute when you're ready to begin again. So for calcium, it has 20 protons. if I'm looking at the number of electrons, I'm looking at the charge that was given. 20 protons with a +2 charge. That does not mean that I add more protons. What it means is that I don't have as many electrons as I should have, right? I'm short by 2 electrons. So my electrons would only be 18 instead of 20, right? If my atom were neutral, I would have 20 electrons. But my atom is not neutral. It has 2 short, right? It's not that I have 2 extra protons. We have to think about that. I don't have 2 extra protons. I'm just short 2 electrons. And so that's where my 18 comes in. And then if I'm trying to look at the number of neutrons, I would take 40. I'm going to round that to a whole number, minus 20, and that gives me 20 neutrons, right? Because 20 right here is my number of protons. So I've got 20 neutrons. Okay, if I'm looking at N minus 3, there's nitrogen right up there. Always 7 protons. That number is never going to change. My number of electrons, however, it says my charge is minus 3. It does not mean I subtract 3 electrons. It means I have 3 extra electrons. So 7 protons plus 3 extra electrons would give me 10 electrons. And then to find my number of neutrons, I would look at my atomic mass, which is 14, minus my number of protons, and that gives me 7 neutrons as well. Okay, let's look one more time at the charge here. 7 protons plus how many electrons would give me a negative 3, right? If I had 7 electrons there, my charge would be 0, right? But I need my charge to be 3 extra electrons, negative 3, and so that number has to be 10 electrons there, right? The negative 3 tells me I have 3 extra electrons. Just like up here, I had 20 protons plus how many electrons gives me a +2 charge, right? Well, I want to have more protons than electrons to give me that +2 charge. So that means I have 2 more protons than electrons, which means I have to have only 18 electrons there. We never, ever, ever adjust the proton number to make work the charge. Okay? We never, ever, ever change the number of protons. The only thing we change is the number of electrons.